High school is a time when young adults are challenged to think more deeply about science ideas and the practices that characterize the discipline of science. Teachers are challenged as well to create rigorous learning environments that engage students from a wide variety of backgrounds. Here we are introduced to Bethany, who has developed a repertoire of skills and tools that supports learning and is responsive to the needs of all students.
I teach at a small high school. It used to be a comprehensive high school, and then it was split into 3 small schools. And our school has a technology and engineering theme. We have a pretty high rate of free and reduced lunch, close to 80%, and the students are very diverse from many different backgrounds. And it's a 10th grade biology class.
So tell us a little bit about this biology class. What are some of the ideas that you address over the course of a year?
The main big ideas we cover throughout the year are ecosystems, natural selection, homeostasis, and genetics inheritance.
So when you think about the whole school year and the progress you want your kids to make across 180 days, what kind of things do you want them to work towards? What do you want them to become better at as the school year progresses?
I think primarily I hope that they get better at building skills around making hypotheses and revising their science ideas.
Does it support or is it neutral or contradict your group's hypothesis? And then you're going to explain why.
And discussing those ideas with each other and then making their thinking visible. So we do a lot of working on using models to propose ideas, share ideas with others, and to revise their thinking.
Since it has less predators, there'll be more here because they can't get them, so it's kind of like the opposite. Because if there's more predators, then there's going to be less hares.
I give some sort of puzzling phenomenon to the students because I really want them to think more deeply about the science, not just kind of the thread you'd follow through a textbook, but really kind of synthesizing ideas and thinking about different aspects of an idea and how they fit together.
You are demanding about having kids do a lot of talk, engaging with talk, not just with you, but with each other. And can you tell me, what are some ways that you, in the beginning of the school year, allow kids to participate?
I think there's several ways that I encourage participation. At the beginning of the year, I set up group roles for their table groups. And in those roles, they have both kind of an intellectual role and a discussion role that they take on. And so they might be the question asker and the leader of the group. So they kind of have to play more than one type of role in their group. And I think that encourages them to realize that they need to both participate in talking with each other and also doing whatever the task is. So I think that really helps build participation in small groups. In whole class discussions, I start every class with an entry question, and I go around and check in with as many students as I can. I try to get to every student. And during that time, I'm really looking for ideas that I can share with the whole class. And so as I look around, I look for things that maybe some student that might be quieter has written down, but they might not naturally just raise their hand and share the class, but then I try to draw that out from them. And then we also often use a chance to write their ideas on the board at the start of class, which allows some of those kids who would be less likely to talk to get their ideas out. And then in their group work with revising their models, I have them use post-it notes, and that's another chance where they can revise their thinking in writing, and so it gets kids who maybe aren't as likely to talk about their ideas to write their ideas. So I think I try to use various access to participate, points of participation for students throughout the beginning of the year and throughout the year.
And do you see kids getting better from the beginning of the year to the end of the year in terms of how they feel they can participate in both the just sharing out ideas, but also participate in like scientific talk and practice?
Yeah, I think I see that throughout the year. At the beginning of the year, I feel like I need to do a lot more drawing out of ideas from students, and as the year progresses, they seem to be more comfortable just volunteering their ideas with me in a whole class setting and also with their group in the smaller group setting.
If I were to visit your classroom throughout the year, what kind of practices might I see happening frequently throughout the year?
Well, there's a few things that we do consistently throughout every unit. One of the first things that we do through every unit is students work with their group to discuss and draw or write a model of their initial ideas. And they revisit that model at least 2 times throughout the unit to revise and think about how their ideas have changed throughout the unit. So that's a consistent practice that sometimes is with a group of 4, sometimes with a group of 2, but is a way that students are continuing to trace the thread of the unit throughout and kind of use evidence from class to revise their thinking.
Mm-hmm.
And then we also use a summary chart, which is a chance for students after each major lesson in the unit to think about what they learned and how it connects to the big idea of the unit and make those connections, kind of to track their thinking throughout the unit.
Mm-hmm. So we'll ask a little bit more about that later, the summary table, but it's a representation that organizes all the activities that the kids
Mm-hmm.
have done up to that point in a unit.
Yes.
Is that right?
Yes.
Okay. And the sense that they've made out of that
Mhm.
particular activity.
Yeah.
Okay. What did you expect your kids to be able to do by the end of the unit?
Well, I expected the students to be able to really create an evidence-based explanation of their thinking about why the population would cycle, both for the lynx and the hare, and the connection between those. And so I expected them to be able to use ideas about carrying capacity and interdependence and energy flow and matter flow, all those disciplinary core ideas in their explanation.
Did you want them to reproduce an explanation that was in a textbook?
No, I wanted each group to really be different. That's something I kind of expect in my class, that each different model is going to be slightly different and use different, maybe emphasize different pieces of information or evidence more. And then also they were I wanted them to revise their original thinking, and so that makes it so that it's impossible to just have everybody's be the same, because they're thinking about how their ideas have changed.
Mm-hmm. So by the end of the unit, were these models different from one another?
I would say yes, they all contained the main core ideas, but the way that they're linked together is different for each group.
Mm-hmm. They made sense of it in their own way.
Mm-hmm.
Okay. And then the way you evaluated these models was based on the logic
Mm-hmm.
that they used to make these links?
Yes.
And the evidence that they used?
Mm-hmm.
Okay. Early in the year, your students are probably not used to this kind of intellectual work, being asked to do these kinds of things. So how early in the year did you support them in getting started at this?
Well, I think the first thing I try to do is do some modeling in front of the class as a whole group, where a few kids have a chance to share their idea, and I really kind of press those kids to explain their thinking. And then when they move to their small groups, I think that the role cards are really helpful in helping them, helping facilitate those discussions and the type of science thinking that I would like them to do, where they ask each other questions and kind of are skeptical of each other's ideas and ask each other if they have evidence and things like that.
Mm-hmm. So these are kind of unnatural ways for kids to talk to each other around the table, right?
Yeah, they are.
So the little cards that you give them each have a role. Can you tell us about what might be on a card?
Yeah, they actually have sentence stems on the cards to help kids ask those questions of each other. So there might be a card that says, "What's your evidence?" or "Why do you think that?" And then there might be one that asks them to ask each other, "Does everybody agree with that?" or "Does anybody disagree?" So kinds of different questions that they can ask each other to probe their thinking more. Because typically students I've seen at the beginning of the year will let one person just kind of have an idea and then they'll go with it, or you know,
there's no questions being asked.
Yeah, they just, okay, that sounds good, and then agree. So.
I see that you have some representations of kids thinking up on the walls of the room, and that they help kids organize what it is they learn. Can you tell us a little bit about their the charts that they had of their hypotheses and how they added to those over time?
So each group on the very first day made a hypothesis poster in which they explained why the hair population would change, and they named their hypothesis. So this group first called it hair versus predator, and then they also called it migration and unbalanced, but then it looks like they crossed out migration. They decided that was not part of their hypothesis. So already they were revising that. And then they're saying it's unbalanced, there's an unbalance between hair and predator, and so that's kind of their hypothesis. And so throughout the unit then, as we did each activity, not only were we mapping it onto that summary chart where they were saying how this activity helped support their idea or somebody else's idea, they were also on post-it notes mapping that evidence to their own hypothesis as a public representation. So they were saying, we just did this activity where we learned about predators, and so we think that supports our hypothesis. And so they would put that on a post-it note and put it on their poster, and that stayed up throughout the unit to kind of help them keep track of how the evidence in class was supporting their model, and then also so they could see how other groups thought evidence was supporting their model, the other models.
Teaching is often thought to be such a private thing. You close your door and nobody will come to see you, nobody should come to see you. And so it's wonderful if we could start changing the teaching profession to be one in which we continually improve by making our practice public, and you've done that, your kids have done that, so I just want to thank you.
Oh, thanks. You're welcome.